Play.
Recording. Okay.
All right. So we'll take a look at where do we hear this term called HL7 and why would that come into picture when we talk about healthcare data. And we'll take a look at hospital workflow because that's where everything begins. And then we will see what is HL7. And then we'll talk about why do we need HL7 and how the name HL7 has come into play, or how the term HL7 has been coined. So we'll take a look at that. Then we will see what is an interface, and we'll see what is the role of HL7 in an interface. And then we'll talk about what is interoperability. And finally, we will conclude our today's session with by looking at the basic structure of an HL7 message. Okay, so before jumping into the actual hospital workflow, let's look at few general terms. So these are the terms that we may be hearing a lot during our entire training. So it's better to understand what these terms mean and how do we use them or where do we use them during the hospital workflow or the entire course. So PM is or PM or PMS stands for Practice Management System. So this is a software used by the front end staff, basically the receptionist or people who are scheduling the appointments or creating patients within the hospital software system. So this is also used to maintain the appointments and appointments of doctors, appointments of various rooms, appointments of various devices, and many more. Okay, but apparently this will hold the administration and scheduling data. It will not have clinical data of the patient. Then the next one is EHR. EHR is a electronic health record, which means this is a software that is used by the doctors to store the patient data. So it will purely have clinical information like what diseases patient has, what is he allergic to anything, did he take any immunizations, uh, and what medication he is currently following. So that kind of data is present in the EHR system. So that is purely clinical related. The next one is HIS. So there are various abbreviations to this. You may call it as HIS, HMS, HMIS, HIMS. Apparently, all of these refer to the same software system. So this software called Hospital Information System or Hospital Information Management System is a software where you have all the modules pertaining to your PM system and your EHR system. So it will have scheduling, it will have patient registrations, it will also have your claim management, it will also have all of your EHR related modules like clinical related windows where you store the entire patient information and all. Right? So that is called as HIS. Next, what you have is LIS. LIS is Lab Information System. So this is a software which is dedicatedly used by the laboratory management uh, organizations. So let's say, or let's take an example of LabCorp or Quest. So they have their own software system to go ahead and punch in or send the orders and get the results back. Right. So entire life cycle of that order and result is maintained within lab information system. Next, you have ICD, which is International Classification of Diseases, and CPD, which is current procedural terminology. These two are basically libraries, and they will have huge list of codes and their corresponding names. So ICD will have a code and its corresponding disease name, whereas CPT will have a code and its corresponding procedure that will be followed in order to resolve any issue the patient has. Okay, so that's how ICD and CPT are used. Then you have three terms, CCD, HIE, and IHE. So these three go hand in hand. Apparently, HIE is and again a concept where multiple hospitals are interconnected with each other to form a central repository. So that is called as an HIE, which is Health Information Exchange. IHE and CCD are standards which will help you to exchange the data with the HIE. Exchange the data in the concept of HIE. All right. So those three will go hand in hand. These three are included here so that you would also know what are the other standards that we have within healthcare industry today. Okay, we have something called as FHIR as well. FHIR is the latest standard in today's world for exchanging medical data. Okay, so in the last session, we will talk about, or in the last two sessions, probably, we will talk about these two standards. What is FHIR? Or how do you look at FHIR and what is the standard all about and all. So I'll give basic introduction about FHIR, and we'll also talk about what is CCD, how does the document look like, what are the contents of the documents, and where exactly it is predominantly used and all. So we'll talk about these factors as well. All right, so let us get started with the basic hospital workflow. So whenever I start my training, I begin with hospital workflow, whether it is HL7 or FHIR training. Both I begin with hospital workflow because that's where everything gets started. So this basic workflow is what we always come back to and take a look at in order to understand the standards better. Always remember, this will be our blueprint for us to go ahead and understand, or for us to go ahead and relate back to whenever we are talking about HL7 messages as well. Okay, so there will be many situations where we'll be coming back to hospital workflow and taking references from the hospital workflow, right? So let's quickly go through and understand what happens within the hospital. So a patient will go ahead and arrive at the receptionist presenting a problem, right? And the receptionist would ask whether the patient is here for the first time or have they been there already. And based on patient's response, they may take a decision of creating a patient or checking with them if there has to be any detail that has to be updated, offering for update of existing data present in the PM system. In case patient has any changes, they will provide that information. If not, they will proceed with the next step, which is scheduling the appointments. So patient's appointment will be scheduled. Receptionist would ask who they want to meet. So that will give provider information and which location they want to meet from, or and which department provider they want to meet and all. So all of these details will be taken, and an appointment will be scheduled with the provider. And this appointment will be sent across to the EHR system. So that's how the entire workflow till the appointment schedule will run. So once the appointment is scheduled, uh, now in the PM system, you have captured the demographic information, which is nothing but patient's personal information. And in the PM system, the receptionist has scheduled the appointment. Now, once these two are scheduled, this information is sent across to the EHR system. As soon as patient gets registered, this data will be carried over to the EHR. How it goes and all, we'll talk about that later. But primarily, the data will flow over from PM to EHR, so that doctor can take a look at who the patient is, what are these details, and also doctor can take a look at the scheduling information in case if he has any appointment for that for any patient for that day. All right. Then once as patient is going to schedule an appointment for the doctor, then doctor will be able to see that so and so patient is about to come, or so and so patient will arrive at so and so time within the EHR system. Okay. So here doctor and the patient will meet for the first time if it is if it's the first visit, and this scenario is called as an encounter. So encounter is nothing but where a patient meeting the doctor and discussing their problem. Okay, and we may hear this term called encounter a lot down the line to represent the scenario or a live interaction between patient and the doctor. Okay, now doctor will try to go ahead and diagnose the problem. In case if they are able to diagnose just by looking at the symptoms, well and good, but most of the times that's not the case. They will go ahead and schedule few orders. So obviously they will perform few tests and uh, will wait for the result in order to conclude what happened to the patient, right? So doctor will go ahead and place an order, and this order will be sent to the lab system, right? And once the lab receives the orders, lab will process that order, it will generate the results and send it back to the doctor. And after looking at the patient's information or after looking at the results, doctor will conclude what the problem with the patient is. And then finally, there will be few charges that will be generated after prescribing medicine to the patient. And this charges will be sent back from doctor's desk to the receptionist desk, lab to the receptionist desk. So at the end of the day, a receptionist will receive the charges for various things, and they will try to go ahead and generate the uh, claim and send it to the insurance company. Okay, and that's where the hospital workflow concludes. Patient leaves the hospital after his interaction with the doctor. They don't pay amount. Mostly in the US, most of the patients, 95% of the patients will have an insurance, and all they have to do is just visit the hospital, get the things done, and leave. And rest of the situations will be taken care by the hospital billing staff itself in generating claim and getting the amount back from the insurance company. Okay. Now let us take a look at the actual problem that is present in world of this data exchange, where patient data is sent over from PM to EHR. EHR again sends a lab order to the lab system. Right. So before understanding this slide, let us go ahead and try to understand what is the let's take a metaphor to understand the things better. Now, let's say there are three different people from three different countries: India, US, and Russia. Okay, and I'm talking about situations that happened back in 1980s. Let's say. So, if these three people have to talk to each other, apparently they have to know each other's language. Let's say, for example, Indian wants to talk to the Russian guy. He has to go ahead and learn Russia, or the Russian guy should learn India's national language, which is Hindi, to communicate with each other. Without that, it is quite impossible for them to talk to each other. Similarly, if they have to talk to US guy, they have to follow the same pattern, right? They have to learn the other person's regional language in order to communicate with them, right? So if it is one country, then that's okay. But if it is, what if the Indian guy or the Russian guy or the US guy has to talk to 10 different people from 10 different countries? Is it possible to go ahead and learn all of them? Obviously not, right? So that's where English has emerged as a common medium of communication, where everyone from everyone from different countries will speak English, and they don't need to learn the other person's regional language at all. So English has provided the solution. English language has provided the solution, and it made communication possible with every person from different parts of the countries or different parts of the world. right? Similarly, whenever you talk about data exchange between different applications, their entire software system is different altogether. Like the way we have people from 3 different countries, similarly, you have 3 different software systems. PM is one software system, EHR is one software system, lab integration system is another software system. And when we talk about software system, it has 2 aspects. It has the front end, it has the back end. Front end is something that you will see on the screen, which will help you to manage or maintain your data that is present and presented in a systematic format. But obviously, front end or the application is not something that would save the data. Every software will have a back end, which is the database. So PM system will have its own database, EHR system will have its own database, and lab system will have its own database. So every system will have its own DB, and that is nothing but having a different language for each component, right? Now, the database structure of PM system is completely different from the database structure of EHR system. Similarly, a lab information system has its own data type. Its own database architecture. So, whenever a patient gets registered in the PM system, the data from this PM database should be sent over to the EHR database. Okay. So, I told you in our previous slide or previous hospital workflow that patient gets registered and the data will flow over to EHR, right? So that's what we are talking about here. Once the data is saved in the database, the data has to be sent over to the EMR system or EHR system. Similarly, when doctor places an order, data should flow over from the EHR system's database to lab integration system, right? So as these 2 databases are different altogether, we would need 2 different integration engineers, one who is an expert on EHR system, another person who is expert on PM system database. Then they both talk to each other on the design architecture on how to exchange this data. Data has to flow eventually from PM system to EHR system, right? So these engineers will go ahead and talk about that on how to exchange the data, how to go ahead and what all data elements do we need? What is the architecture of the database of PM? What is the architecture of the database of EHR? So they will need to perform thorough analysis to make sure that this integration is possible, right? And eventually they will go ahead and create an interface which can exchange demographic data or scheduling data. But that will take a lot of time, right? Because they will have to discuss in detail how they want to exchange, what they want to exchange, what is the format they have to use, what is the connectivity model they have to use, and many more aspects of integration, right? So it will take a lot of time and lot of resources in order to build one single interface. Okay, that's where HL7 V2 has come into play as a solution. Okay, so what HL7 version 2 does? So HL7 has implemented a standard like the way we have English language. HL7 V2 represents English language from the example that we have looked at. Even though the databases have different architectures, if each of these system can generate an HL7 V2, it can just send that HL7 V2 message to the EHR system or to the lab information system wherever it is needed. And the other person or the other side of the system, let's say PM is generating a demographic data. Demographic is nothing but registration information. So if PM is generating a registration message and sending it over to the HR system, and while sending it, it is sending it in the form of an HL7 message, then EHR should be able to interpret that HL7 message and then write the data within their system. Okay, so this is the general expectation. No one needs to know what is the DB design of the other application. All that they have to do is they should know thoroughly about their application, and they should be able to generate their own HL7 message. So if they are able to generate HL7 message, then that's fantastic, right? And they can send out the HL7 message, and receiver should be able to interpret that, because that is a common medium or common data exchange mechanism that is being driven back in 1980s when it all began. Okay, now what are the benefits or advantages of this? Now, if you have a standard, you don't need to discuss in detail how you want to exchange the data, what is the format that you have to follow, because everything is predefined in the standard. What is the connectivity model that you want to use and exchange the data with, and you don't need to reinvent the wheel. They have already drafted all the steps that are needed to construct an HL7 message and follow the standards, right? And believe me, from the last 30 years, almost 35 years, we are using HL7V2 as the primary medium of data exchange between hospitals and labs and various healthcare entities. Okay, not just earlier it started predominantly in the US, but in today's world, not just in the US, but also many European countries, Australian countries, and uh, many more countries are using, Middle East countries, many more countries are using HL7V2 as their standard mechanism of data exchange protocols. Okay. Now, that being said, we understood so far that applications are different. They need to talk to each other. In order for them to talk to each other, HL7V2 is the medium of communication. So patient gets registered, HL7V2 message gets triggered to the EHR system, right? So whatever events happen, they do represent HL7V2 as the medium of transaction or medium of communication. Now let's see what is an interface. So when we talk about an interface, usually interface is nothing but a bridge or a tunnel which will connect data or application PM system to the HR system. And when it connects, it will enable exchange of data through HL7V2 messaging standard. Okay, or through HL7 language, you can say that. Okay, so what I'm trying to represent here is that HL7V2 messages exchange between two different applications. Apparently, they connect one database to another database. It doesn't matter which database it is, because the HL7 messages are generated at the application level. Let's say PM is using Oracle database, EHR is using a flat file database, or maybe it is using a Derby database, right? It doesn't matter which database it is, because at the end of the day, it is generating HL7V2, and this is being exchanged through an interface. Okay, so your primary work would be to build these interfaces or maintain or manage these interfaces, apparently, which is nothing but a tunnel that we build between PM and EHR to exchange the data on a daily basis. Now, what is HL7? So basically, it is a messaging standard. For now, we will call it as a language until we complete today's training, so that we can relate few things back to a few English language syntaxes and all. So apparently HL7 is used to talk to other computers. The name comes from something called as Open Systems Interconnect, which we will see in the next slide. And it will tell you how did we coin the term called HL7. And HL7 is well developed, and it is used in, as I said, many different countries. India is also one of them. Now let's take a look at the factor of why do we have this name called HL7. So HL7 is purely based on open systems interconnection model. So what is open systems interconnection? This is a beautiful model uh, because I was fascinated when I got to know about this for the first time. And I was trying to research and figure out why do we have this name called HL7? Very unique name, right? So I was wondering what triggered that name. So that's where I was trying to understand, and I came across this model called as OSI model in order to know why we have this name called HL7. So you can read it in detail, but just to give you a high level overview, let's say I am presenting something on my screen and you are seeing it on your screen. How is that possible? Right. So there is something that must be happening, which is actually showing whatever I am presenting right now in real time to you guys. Right. So just imagine that the top layer that you're seeing is nothing but the application layer. And just imagine that behind that, there are 6 more layers. Okay. And these 6 layers are basically converting the data into packets. And you can see here that we have physical layer, which is connected to your Ethernet port, okay, or your Wi-Fi. And this physical layer will connect to the external entity and send those packets that got generated. So the entire application that I am presenting in the application layer, which is nothing but the application that we see on the screen, will be broken down into series of packets, and that will be sent through the physical layer to the Ethernet cable. And these packets are traveling all through, and they are reaching your system's physical layer, and they are interpreted back and presented in your application, which is nothing but your front end. So that's how you are seeing it right now. So every layer has its own significance, what it does, and there is a lot that goes on at each layer, but everything happens in fraction of milliseconds, right? So OSI model is a very good model. Just go ahead and read through it, understand it in detail. I mean, not very much needed for our HL7 training, but it's good to know information on what it does. Now, what we are interested here is what happens at the application layer. Okay, HL7 operates at this level. If you want to construct an HL7 message, there should be an application, and that application should go ahead and deal with the data, extract the data, construct HL7 message, and so on. And all of this is done at application level. Okay, so that is the reason we have this term called, or number called, 7. So that's the 7th layer. Application layer is the 7th layer, and physical layer is the first layer. And HL stands for health level and number 7. So that's how that name HL7 has been coined. So like any other languages, HL7 will have its own grammatical syntax. HL7 version 2.3 has widely been used. Then after that, 2.5 is something that we have that has been used greatly, but behind 2.3. All of the HL7 messages have something called as data types, message types, and event types. Okay, you may not understand that if you are into HL7 for the first time, but don't worry, we'll take a look at each of these aspects in detail later down the line. But just we need to understand that these are the 3 different categories of information that will be present on the, or that will be there on implementing this standard called HL7. Okay, next let us talk a little about the history of HL7. Right, as I said, back in 1980s, late 1980s is where HL7 has started to solve the problem that hospitals are facing, because in order to build one interface, it would take a lot of time in case if messaging standard was not there or this language was not there. So it was released back in 1997 as an official release, which is 2.3. Earlier or prior to that, it was 2 or 1, or maybe maybe a standard for trial use, something like that. Okay, but 1997 marked the first release of HL7 V2, and that is with version 2.3. And then you later had subsequent versions as well. And in 2005, you had in 2003, you had version 2.5 released. And then in 2005, you have version 3 released. And then later in 2014, you got version 2.8. So now this is little surprising. 3 got released, but after that, 2 was enhanced. So that is a little surprising. right? Because once you move to the higher version of the standard, it is quite rare that we go back to the lower versions of it, right? So, but there is a solid reason and a significance here why that really happened. So HL7 V2 is based on something called as pipe delimited structure and all, whereas HL7 V3 is completely designed, and the messaging structure, the way you change the data or exchange the data, or a lot more, is completely different from when you compare to the HL7 V2. Okay, so that is the reason why it was not very much welcomed by the industry, because of the complicated structure of HL7 messaging. And one more important thing is that there was no significant value addition in case if we move or implement version 3. Okay, so that is also one of the primary reasons why it did not progress further. Okay, so version 3 was not acceptable by the industry, and you will not see much interfaces on version 3. But as part of version 3, there is another standard that is released called as CCD. Okay, and CCDs really helped a lot in the industry. Okay, and after that we have Fire. So many are asking me, Fire, is it same like HL7? What it does? Is it different? Or HL7 V2, will it be replaced with Fire? Many questions do come, right? So Fire is a latest standard for exchange of healthcare data. And again, it started back in 2010 as a small project, but later it got extended beyond just being just being a simple standard. And today it is a full-fledged messaging standard to exchange data between different applications. Now the question comes in, is it same like HL7 V2? No, HL7 V2 structure is totally different when compared to Fire. And Fire really helps you to go ahead and uh, exchange data through the latest technologies that we have. So it differs from HL7 V2 in that way. Can it replace HL7 V2? It can. The intentions and idea behind developing one of the paradigm in Fire is to replace HL7 V2, but it will take a lot of time. Reason is Fire is still evolving, and it is not a normative standard. Normative in the sense it's not a standard where we can say that things don't change within that standard. Okay, things tend to change because Fire is evolving day by day, and it will take a lot of time for it to become stagnant and standard. And so until then, Fire and HL7 V2 both should coexist and will coexist for a very long period of time, maybe another 5 years or 6, 7 years, so that things could be pretty strong in terms of Fire. Not only that, if someone is implementing Fire instead of HL7 V2, they would definitely see the advantage over HL7 V2. And if there are existing implementations which are already built on HL7 V2, they may see for what is a significant value addition if we move from HL7 V2 to Fire. So those kinds of analysis will be done. And if there is significant value, then people may move. But as I said, both will coexist for a very long time. Okay, I'll pause here for a second. Any questions from anyone so far? All right, so I'm not hearing anything, so let's continue. So what are the advantages of having this standard? This will help us to share medical data, demographic data, billing data, lab information data, and all with HL7 enabled applications. So whichever application can construct or generate and interpret HL7 messages, those will be in advantage because they are exchanging digital data. And data transfer is in the form of messages, which means they are based on events. And then no special tools are required in case if application can generate it. If not, then we just need one integration engine for us to manage and maintain this entire aspect. Code is in ASCII format, which means human readable. When you look at an HL7 message, even if you don't know the structure or anything as such, if you observe, you will be able to definitely figure out few of the data elements, at least name, date of birth, gender, or address or phone number. This kinds of information can be easily identified from the HL7 message structure. It is completely operating system independent. It can connect from any system to any other system because this operates at application layer. So every OS has an application layer, and it doesn't matter which OS you are using. So it is not operating system dependent too. Why do we need this standard? So we'll come back to the basics again. When we talked about hospital workflow, if we do not have a standard, two applications to integrate each other, there has to be a lot of discussion. The format of data to be exchanged, which connection model we will use, what is the structure that we have to build, to exchange the data. Not that it is not possible, it is possible, but the time consumed to implement one interface, maybe 1 year, 1.5 year, and so on. But with HL7 standard, it comes down to the 1 month or 2 months. Okay, that is purely because you already have a standard in place. That standard tells you how you want to exchange the data. All that you have to do is just follow through that, and you don't need to reinvent the wheel in discussing how we want to exchange the data, what are the protocols that we want to use, what all data elements to include. All of these discussions are not necessary. All that you have to do is go back to the reference of the standard, refer it, and implement it. So most of the work is already done. All that you have to do is just follow through that and implement it. So that's the reason why we need standards. And this will help in sharing of medical data quickly and generate insurance claims without human intervention. There will be mostly an error-free insurance claim mechanism. And then you have the interoperability in place, which means applications talking to each other is called interoperability. So apps will be able to talk to each other, and then you have greater safety for the patient because it maintains utmost quality where human error is very, very low because you are exchanging data through uh, the interfaces. Now, let us quickly try to understand how HL7 messaging works, right? So when you talk about HL7 messaging, it is purely based on one simple principle called trigger events. So what is a trigger event? In order to understand trigger event, let's break down this term, trigger and event. Let's understand what is an event first. Okay. So let's go back to our hospital workflow again. Whenever a patient arrives, receptionist would ask whether they are here for the first time or they have been to the hospital earlier. Now, based on the answer, receptionist will go ahead and take certain action. If patient is new, they will register. If patient is existing, they may update existing information. So there are two events that are happening. If patient is new, they will go ahead and create a new patient record altogether in the PM system. And once they capture that information, they click on the button save in their application so that the patient data can be saved within the application. So that is one event. Next, patient has an appointment scheduled. So that is another event. Then patient meets the doctor. That's another event. Then an order is placed. That's another event. In this way, entire hospital workflow is divided into series of events. Okay. And these events will trigger the data from one system to another. Okay. So an event is happening and that event is triggering the data from one system to another. Hence, it is called as trigger event. So HL7 messaging works on these trigger events. Okay. So we will talk more about what trigger events are, what are the different types of trigger events that we have and all in tomorrow's session in detail. But just to give you an idea that HL7 messaging standard is based on these trigger events. Okay. So when we look at the entire hospital workflow, there are series of uh, things that would happen within the hospital. You will have registrations, you'll have appointments, and you will have labs, you will have pharmacies, and you will have invoices that will be generated. Now, let's take a look at the anatomy of the HL7 message. So, let's look at the actual HL7 message structure, right? So, let's take one small example to understand these things better. Let's say that we have a cupboard. Let's say we have a cupboard in a house, right? We organize our cupboards. And in the cupboard, you may have different shelves, and each shelf may be again divided or dedicated for various materials. So first in the cupboard, first shelf would represent or is dedicated for clothes. Second rack or second shelf in the rack is divided or is used for books. And the third rack or third shelf is used for another set of books. And each shelf is again divided into different compartments to store various things or to categorize various clothes, right? Now, let's say there are two people in the house, and those two people, one of them is going out on a vacation, maybe probably, and he forgot his t-shirt at home. And he calls the other person who is at home and he says that, hey, can you get me that t-shirt? And the person who is at home will access the cupboard and go to the first shelf, first compartment, get the t-shirt, and he gives that t-shirt or sends that to the person who is leaving. Now, when you talk or when you see the discussion between these two, the person is asking only to get the t-shirt and the second person was able to get it. How? Because they know the structure. They know how the data, how the information is, or how the materials are organized within their house. Another example is, let's say there is no power at home. I'm talking about situations back in 1980s. There is no power at home. What is the first thing that we do? Even if it is total dark, we navigate to a place where we keep our candles or our torch lights, right? Even if it is dark, we are still able to do that because there is a standard dedicated place for each of these items that we want to store in our house, right? HL7 also works on very similar principle and factors. Whenever you want to go ahead and exchange or send data in an HL7 message, there are dedicated placeholders within the message. Okay, that is the basic uh, aspect that I wanted to communicate here. There is dedicated placeholder for each of the data element. Let's say when patient is getting registered, you capture a lot of data. First name, last name, date of birth, gender, address, phone number, email address, insurance information, and a lot more of data elements, right? Each and every data element has a dedicated placeholder within the HL7 message structure. That's how HL7 messages are generated. We'll see them down the line on what are these data elements, what is the position or placeholders of these, but let's understand the message structure first. So if we talk about HL7 messaging, it follows very similar principle of what you're seeing on the screen now. The architecture of one single rack and then having shelves and each shelf divided into components. Let's see that. So any HL7 message will have or is basically comprised of segments. Okay. And these segments are divided into fields. So there will be multiple segments in an HL7 message, and each segment is divided into fields. And then fields are further divided into components and subcomponents. Components are again divided into subcomponents. So that will be a hierarchical structure of any HL7 message. Okay. So at the higher level of the hierarchy, you will have the message, and then you will have segments. Segments are divided into fields. Fields are divided into components. Components are divided into subcomponents. So let us take a look at the grammatical syntaxes before actually looking at the actual HL7 message structure. Let's understand the grammatical syntaxes, and we'll go ahead and jump and take a look at the message structure. Like the way we have our English language, we have punctuations, right? Those are our grammatical syntaxes in English language. We have full stop to tell the end of the sentence. We have exclamations to express various expressions, and then you have various aspects in English. In the same way, when you want to read an HL7 message, you should know the punctuations of HL7 message. So those are called as message delimiters. Okay. So the first one that you see here is segment terminator. It's exactly like full stop. Segment terminator will tell you what that this particular segment has concluded. Okay, it is present at the end of each segment so that the reader and the systems would know that this segment is completed. Next, each segment is divided into fields is what we have seen in our previous slide, right? So every segment is broken down into fields with the help of a symbol called as pipe. So this second symbol that you're seeing here is called pipe. Then you have something called as component separator. Within a field, you have data divided into two components. So those are divided with the help of this symbol called as caret. Then you have an ampersand and tilde. We will talk about this down the line as in when we come with examples. As of now, we need to understand primarily the field separator and component separator. Okay, then we have escape character as well, which is a backward slash to escape the data or few data elements when we are exchanging the data. So we'll talk about that as well down the line. So now let's look at one sample HL7 message. So this is how an HL7 message would look like. So we saw the structure previously that HL7 messages are divided into segments. So there are 5 segments here. 1, 2, 3, 4, 5. All of this together comprise of one HL7 message. How many segments you can have? You can have as many as you want. It purely matters or purely is dependent on what kind of event is taking place. If it is registration, you may have 3, you may have 5, and you may have 6, depending on the data that you want to exchange. Okay, so there is no definite number on how many segments you can have. It is purely dependent on what is the event that is taking place. If you observe, each segment is beginning with a 3-letter acronym, right? MSH, EVN, PID, NK1, PV1. So those are the 3-letter acronyms that we have for each of these segments. Those will represent the name of the segment. Okay, so let's just paste this on Notepad and take a deeper look at it. So let me set the language to JavaScript. JavaScript, it's not JavaScript, by the way. I'm just using it so that it beautifies the data and we can see the differences clearly. So now if you look at these segments, each of these segments have their own name. MSH stands for message segment header, EVN stands for event, PID stands for patient identification, NK1 stands for next of kin, and PU1 stands for patient visit. That way, each segment has its own name, and as you can see, each name is dedicated for certain data category, right? Patient visit will carry visit related information. Patient identification will carry patient identification related information, and so on. Okay. Now we looked at the structure and the segments. Each segment is divided into fields. That's what we have understood from our previous slide. So if you consider just the PID segment here, Okay, so because patient identification data can be understood easily, right? So you can see that there are data elements that are present between the pipes. So this is one data element. This is second data element. This is another data element. This is another data element which is blank, and this is another data element. So whatever is present between two pipes is called as a field. So this is one field. This is another field. This is another field. This is another field. This is another field, and so on. How many fields we can have? That is dependent on what kind of segment you are looking at. For example, in PID, you have 40 fields. Version 2.8 PID will have 40 fields, and each field is there to represent certain kind of data. Okay. For example, if you look at this here, test John, basically it's the name of the patient. If you see here, you have patient's date of birth. Okay. Now, if you look at this, and if you try to go ahead and count the position where it is present, you have field number 1, field number 2, field number 3, field number 4, and field number 5. Right? So in that way, there is something called as field positioning. So every HL7 message will have segments. Segments are divided into fields. Each field has a number, which is nothing but field sequencing or field positioning. And PID 5 is always dedicated for patient. Okay, PID.5. So here I am representing that, or I am asking someone to go take a look at PID segment and see what is present in PID 5. And when they go look at the message, they will understand that PID 5 is patient name. And universally, this is standard. Whenever someone wants to send the name, they have to send it in PID 5. So this way, when HL7 message is generated from PM system, PM will go ahead and send the name in PID 5. So the receiver, whoever receives it, they will go ahead and check in PID 5. That's all. There is no discussion on, okay, if you, in which field you are sending the data. This all is predefined. All they have to do is go ahead and follow the structure that is provided to them by the HL7 message. Okay, so that's how you start reading the HL7 message. In tomorrow's session, we will take a deeper look at how do we read components, how do we read various fields, uh, and understand the importance of components and all. But in today's session, we understood what is the structure of the HL7 message. We understood that it will have segments, and each segment is divided into fields. Each field has its own positioning number. Okay. At the end of each segment, you will have something called as carriage return, which is nothing but the segment terminator. Okay. At the end of each segment, you will definitely have a CR. If you do not have, then the programs will not be able to break down each and every individual segment. So CR is mandatory always at the end of the segment. Line feed you may have or may not have, but CR is mandatory. Okay. So let's go back to our presentation. So training and certification, anyone can be trained on HL7 if they want to. So if it is basics, all of these people who are at executive level or programmers in healthcare, doctors can also learn HL7, and IT administrators can also learn basic stuff of HL7. Intermediate and expert, this is dedicated, or this level of learning is dedicated for people who are exclusively working in terms of development, testing, supporting, and all. And they would definitely need to have good knowledge in terms of implementing or developing these aspects of HL7. Okay, so in order to summarize, just to see what we have seen today, we just looked at how HL7 is mandatory for exchanging healthcare data between two different applications, which is nothing but interoperability. And obviously, it is becoming I mean, it's now evident in the whole world that HL7 is the go-to standard in order to go ahead and exchange medical data between two different systems. Okay, so any questions from today's session? All right, I'm not hearing anything. So, few couple of things for your information. So this training is divided into training which will happen 5 days a week, um, and every day it will be an hour session, same time, 7 to 8 is Indian Standard Time, uh, and we'll have 45 minutes of session, 15 minutes of questionnaires. In case if you have any questions for that day, we'll discuss during that time that we have. Uh, and then this training will span over 6 to 7 weeks. It will have around 30 to 32 session, 30 or 32 sessions, uh, and which is divided into two parts, as I said earlier. You will have first part for HL7, where you'll have around 10 to 12 sessions on HL7, and rest of the aspects are purely for Mirth Connect and understand what is an integration engine, how do you generate HL7 messages, and much more. Okay, and today's session, tomorrow's session, you can feel free to join tomorrow's session as well. But from third session, whoever is enrolled for the training will be given a new training link, and they will have to go ahead and join this one. Okay, and is the session recorded? Yes, these sessions are recorded. In case if you could not attend the session, daily recordings are uploaded to the Google Drive. Whoever is enrolled to the session, they will enroll to the training. They will be given access to that. And if you cannot attend that session, you can go through the recording. And if you have any questions, you can post it in the WhatsApp group. So once everyone enrolls, we will be creating a WhatsApp group for quick communication, and we will use that as medium for us to go ahead and exchange any questions that we may have, or you can ping me directly if you have any questions that you don't understand after listening to the recording, and get ready for the next day session. So we'll take care of that. How do you enroll? Yeah, for that you can contact Mr. Srinivas. Let me go ahead and just paste his number here. Um, and you can reach out to him on WhatsApp, and he will help you in addressing or letting you know the procedure in order to go ahead and uh, enroll for the session. Okay, that's Srinivas' number. You can just WhatsApp him on this number. Okay, I'll share US number as well. All right, that's the US number of Srinivas, and this is the Indian number. Okay, you can just quickly check with him. All right, any other questions from anyone? Okay, I'm not hearing anything. So let's go ahead and conclude today's session here. We will catch up tomorrow. In tomorrow's session, we will take a look at what is a trigger event, what are the various types of trigger events that we have, how do we read a trigger event in an HL7 message, and we will also take a look at we'll divide the entire hospital workflow, whatever we have seen today, into various events, and we will see how to or what names do we have for these events in the hospital, in the HL7 methodology. And we will also take a look at what we have looked at today. We will talk about HL7 message structure, little more detail, and how do you read HL7 message, what is a component, and couple of other aspects of HL7 message structure. Okay. All right. Okay, there is another question regarding the certification. Are we getting guidance? Yes. So that's a good question. So whatever we are going to go through the training will cover 70% of your certification content. Okay. And in the last one session, there will be a dedicated session where we'll be talking about what all topics you have to go through, and what all chapters or what all books you have to go through from the HL7 specification, list of documents that you have, what is the weightage for each of the topics is what we'll take a look at. And we'll also share few sample questionnaires which you can go through in order to prepare for your certification if you're planning to. Okay, so definitely that guidance will be given. And in the last 2-3 sessions, once we complete Mirth Connect, we are going to take a look at all of these things. Certifications. We'll also talk about fire. I will explain you the basics of fire so that you know where to go ahead and look for fire. I will also tell you about the basics of CCD, what is CCD, what is HIE, and all of these things, so that you know where to start from in case if you have to get started with other standards in healthcare today. All right. Any other questions from anyone? Okay, I'm not hearing anything. So let us go ahead and conclude today's session here. Thanks everyone for joining and showing your interest in this. We'll catch up tomorrow. Feel free to join tomorrow as well if you're having time and would like to know more about HL7 messaging. Thanks everyone. Have a good day.